Hello everyone and welcome back again. Today we have an interesting question on forces and I'm going to help you understand this concept as we solve this question together. The question reads, three blocks of masses M1, M2 and M3 are connected by massless strings as shown on a frictionless table. They are pulled with a force T3 equals 40 newtons. If M1 equals 10 kg, M2 equals 6 kg, and M3 equals 4 kg, then the acceleration and tension of T2 will be what? Okay, so first thing that you need to know here is that as long as we have T1, T2, and T3, it means that the tension in the strings are not the same. They differ. T3 could be 40, T2 could be something else, and T1 is also different. So that's one thing that you need to know. Now, the second thing is that friction is not involved. So we don't consider the force of friction in this case. We only consider the tension in the strings and how they affect the movement or the motion of these masses. So we are asked to find T2, and tension is a force. So that means that the second law of motion is going to apply in this case. Let me show you how to find the second tension, or T2, when given three masses. So we say solution. We have to analyze them independently. Okay? So here we have our M1 to be 10 kg. Our M2 is 6 kg. And then our M3, which is the third mass, is 4 kg. And we were also told that the tension on the in the third string is 40 newtons. Okay, now let's go ahead and solve this problem. We are going to analyze them separately and create three equations. So if there were two masses on this table, we end up creating two equations. If there were only one, we create one equation. But since there are three, we're going to create three equations for them. So we say object 1, this is how you're going to do it. Object 1, we say summation of forces in the x direction equals m1a. Okay, the acceleration would be the same for all of them, but the only thing that's different is their tension. So we say summation of forces in the x direction is equal to m1a. So here we have how many forces are acting on mass 1. So we quickly draw a free body diagram for mass 1. Looking very closely here, we can see that this is our mass 1. Let's use a dot to represent that. There is only one force acting towards the right. So the masses are moving towards the right. And all the forces that are lines perfectly in the direction of motion are considered positive forces, while the forces that are in the opposite direction are considered negative forces. So this is our M1, and there is only one force pulling it to the right. They are moving towards the right. This is the direction of motion. You can see the arrows as indicated. So this is only T1 acting on mass 1. Okay, so there is no negative forces, or there is no opposing force right here. So there is only one force acting upon it. So we say all the forces acting upon T1 or acting upon M1 is just T1. So we say T1 is equal to M1A. So let's substitute our values. Our T1 is equal to, for the mass 1, we have 10 multiplied by A, and then T1 is equal to 10A. So we call this our equation 1. You might be wondering, why am I analyzing T1 when we're asked to find T2? So we are actually going to use T1. It's going to help us to find what we're looking for. So don't try to play smart with this kind of question. Always analyze them separately whenever they come in your exam. Now we're done analyzing T1 or object 1. So let's go for object 2. So we say object 2. Now I'm also going to draw another dot here. Now looking at the second object, which is M2, we have M2 as a dot, and then you can see very closely here that T2 is pulling M2 to the right. This is T2 pulling to the right, and then between M1 and M2 you can also see that there is a string, or there is a tension force in between. So this force is actually opposing the motion. Okay, so this is our M2, and M2 has two forces. This one here is T2, and this one here is negative T1. You can see right here. So this is M2, and between M2 we have T2 and T1. Since M2 is moving towards the right, T2 is positive, but it's not moving towards the left, so T1 is going to be negative. Okay, so make sure you understand this. Consider the direction of motion. All the forces in the direction of motion are considered positive, while the ones that are opposing the motion are considered negative. So this T1 here is kind of trying to pull it backwards in this very case. Okay, so that is what it's actually doing. Don't forget to analyze them very correctly. So we say, okay, since there are only two forces, no upward force, no downward force, we say summation of forces in the x direction is equal to m2a. Okay, we use the same a for all of them because the acceleration would be the same. Again, we say all the forces in the x direction for object 2 are, we have T2 as a positive force, which we're looking for, minus T1, and this is equal to M2A. Moving negative T1 to the other side, we have T2 is equal to M2A plus T1. Again, we can just substitute. So we have T2 is equal to, our M2 is 6 multiplied by A, that gives us 6A plus T1. And this gives us our equation 2. Okay, now you know how to analyze them. Let's now look at object 3. So object 3. We also represent that by a dot. And then our object 3, which is M3, you can see here that T3 is pulling to the right. Okay, and again, we have negative T2 because at the center we have M3, which is object 3. Then we have a force on the left, on the right, and another force on the left. So this now becomes, here we have T3 pulling to the right, and this is T2 in the opposite direction. So this now becomes negative T2. Okay. So we write the equation and say summation of forces in the x direction for object 3 is equal to M3A. Again, the forces that are acting on M3 are T3 minus T2. This is equal to M3A. All right. So right now, since we're looking for T2 and we have the value of T3 already, we can just plug it in there. So we have 40, because that's the value of tension 3, minus T2 is equal to M3A. Okay, so moving negative T2 to the right and M3A to the other side, we have 40 minus M3A is equal to T2. So writing this nicely, we have that T2 is equal to 40 minus M3A. And this is our equation 3. Okay, now we're almost there. Okay, we're actually looking for T2. So what we're going to do right now is that if you look very closely here, we have two equations that can give us T2. We have equation 2 and equation 3. So what we do is, since we know that T1, looking very closely here, we know that T1 is equal to 10A. So I'm going to substitute the value of T1 into this equation here. So let me solve that simultaneously. So solving simultaneously. We have T1 is equal to 10A. T2 is equal to, here we have 6A plus T1. And then T2 again. T2 is equal to 40 minus M3A. Okay, I'm going to substitute the value of T1 into equation 2. So this now becomes T2 is equal to 6A plus 10A. Okay, since T1 is equal to 10A. Then looking very closely here, we can see that T2 is equal to 6A plus 10A, and then T2 again is also equal to 40 minus M3A. So we can just equate them since they are the same. You can see T2 and T2, so we equate them. Here we now have 6A plus 10A is equal to 40 minus M3A. All right. Now, what's our M3? Our M3 is 4. So here we have 6A plus 10A. That's 16A is equal to 40 minus our M3 is 4 multiplied by A, that's 4A. So moving the negative 4A to the other side, we have 16A plus 4A is equal to 40. 16A plus 4A is 20A. This is equal to 40. So when we divide both sides by A, so we have 20A over 20. When we divide both sides by 20, this is equal to 40 over 20. So when we divide both sides, we have that 40 divided by 20. Our A is equal to 2 meters per second square. So this is the acceleration of the system. And having found the acceleration, we can now go ahead and find our T2. Okay? We can find our T2 having found the acceleration. So any of these equations will do. We can use any one that we want. We can use this one here that says that T2 is equal to 6A plus 10A. So let's see. Solving for T2. So we say that T2 is equal to 6A plus 10A. This is equal to our A is 2, so we have 6 multiplied by 2 plus 10 multiplied by 2. 6 times 2 is 12 plus 10 times 2 is 20, and that is equal to 32 newtons. So this is the value of T2, 32 newtons. We can also confirm using another equation. Here we have that T2 is equal to 40 minus M3A. So let's see. T2 is equal to 40 minus M3A. So T2 is equal to 40 minus, our M3 is 4, our A is 2. So T2 is equal to 40 minus 4 times 2 is 8. So T2 is equal to 40 minus 8 is 32 newtons. So no matter the equation you use, you always arrive at the same solution. Thank you for being there and see you in the next video.